Here we go. Last section on inheritance. This is the Object Superclass. Let me close that there. Blue. Object Superclass. And if you want to put a number to it, I believe it's 9/7. Today is 2/21/20. All right. So the Object Superclass, what do we already know so far about the Object Superclass? Well, everything inherits from it. Even if you don't write that a class extends, it's going to automatically extend object, which means that every class extends object in one way or another. If you were to draw out an inheritance hierarchy, object would be at the tippy top of every single inheritance hierarchy. It is the breath of life, the spark of life through which all other objects gain their, I don't know. Yeah, in the beginning, there was object. That's what you can say. In the beginning, there was object. So, that being said, if you were Java, what behavior would you want every single object to have? Because if you put that behavior in object, then you're guaranteed that every single subclass is going to have at least that behavior if it doesn't override it itself. Does that kind of make sense so far? Okay, so if you were Java, what behavior would you want every object to have? As if by magic, class object has methods built in for all classes you design without the code extends object. Think of the object class as the root of all other classes. It is the cosmic superclass. I think we've looked at it before. Literally, if I Google cosmic superclass, it's object. It's not just me saying it. It's literally called the cosmic superclass. That's its literal name. Now, you won't be tested on that at any point, but that's kind of what it gets called because it's the root of all other classes. It says if you look at the Oracle documentation on the object class, you will see many methods that all Java objects inherit. I was going to pull that up really quick. Java object class. And show you guys what it kind of looks like here with Oracle's. Oracle is the company that kind of keeps track of and maintains the Java code. Have you ever heard of the company Oracle before? Do they own an arena? Like the Oracle Arena, is that?
Golden State Warriors.
Golden State Warriors, okay. So they're a very big company. So here's object. Here's the methods that object has. There are two. These are all the methods that object has. There are two on this list that we use often. Which are they? toString and equals. Okay. So the rest of these, if you didn't know it, all of your classes have these, whatever these waits and notifies and finalize and get class are. Get class is kind of an interesting one. It tells you what the class of an object is. That's kind of interesting if you're ever curious. But basically, the two that we are most interested in is equals and toString. Now, one thing about overriding. When you override in the subclasses of object, remember to override your method's signature must be the exact same. So we've talked about it before with toString. toString just always looks like public string toString. That's not very interesting, but it always looks like public string toString for the toString method. What about for equals? Well, the equals method always must receive a capital O object, which is a little tricky because we're not going to just want to compare capital O objects. We're going to want to compare triangles to triangles, apples to apples, oranges to oranges, and so on and so forth. So how are we going to override that method and take in a single object? We'll talk about that in a little bit. It will involve some casting eventually. But the big thing you need to know is that object, everything inherits from object, and there are two specific methods from object that we need to know, toString and equals. This sheet right here, by the way, is the sheet that you will be given on the day of the AP test. I will give you one for our exam in this class as well. This quick reference sheet should be like a security blanket for you. It should make you feel comforted, but I'm hoping at this point you've grown out of needing it. but only in your deepest, darkest times. Just knowing that it's there might give you a little bit of positivity, but I'm hoping that we don't need to use it that often. On the day of the test, if you've forgotten what index of or how substring works, then, you know, there might be some issues there. But it is here for you, and it contains kind of what methods are available to you and all that kind of stuff. If you look at the very, very bottom, you'll notice two methods, equals and toString. Those are the only two methods you need to know that exist in Object, and the only reason we need to know them for Object is we're basically going to have to override them in a lot of the classes that we write. So I'm going to write down some stuff about Object here really quick. Object. Let's see. First of all classes are an, where's my red? There we go. Instance of object. All classes are an instance of object. If you don't say you're extending anything, you're still extending object. It's at the top of the class hierarchy of any single class hierarchy that you can imagine in Java. You need to know two methods for the AP test. And those two methods are public string toString If you were explaining to your friend that doesn't know anything about programming what the toString method does, what would you tell them? How would you describe what a toString method does?
It's like the
Java to English translator. I like that. Java to English translator. Okay. What else about toString? Annie? Yeah, I like that. It simplifies. I'm gonna say like it shows you like instance variable values. If you write it correctly, it should. I mean, I kind of say sometimes it's like a baseball card. It gives you like all the statistics about your object. When is the toString method called? There's something special about the way that's called. Yeah, when you print out an object. Called implicitly when you print an object. Called implicitly when you print an object. Something's happening outside of my door. Alright, so it's called implicitly when printing an object, and hopefully it says something like the different instance variables and their values and stuff like that. Before we write down the stuff about equals, any questions about toString, first of all? If you are overriding it, you must have that exact method header. Public string toString, no parameters. You can't say public string triangle toString. That would not override the toString method. The method header must be exactly that, public string toString. Exactly that method header. No options, no creativity. All right, let's keep reading here before we talk about the equals method. One commonly overridden object method is toString, which is often used to print out the attributes of an object. It's a good idea to write your own toString method in every class. Do you guys remember what happened when we don't write our own toString? We get that weird gobbledygook that says like triangle at 1F2B47D, something like that. Okay, we don't want that. So that's the one that pops up for object. We don't want to use that one. In a class, toString can call the superclass toString method using super.toString and then add its own attributes. I think we know that too. In the following code, the person class overrides the object toString method, and the student class overrides the person.toString method. Let's see if that's true. Here's a person. A person is defined as having the attribute of name. There's its constructor. It just sets its name. Here's its toString method. It just returns its name. So when we go ahead and make person Scylla, and print her out, we should just see Scylla. I see Scylla. Then we make a student object. Let's see. Student has an extra attribute, an ID number. You'll see that the constructor for student takes a name, sends it to person, and then it specifies an ID number. And then it overrides, but also calls the toString method from person by saying return super.toString. What is super.toString for person? Just the name, and then an ID number. So that's why we see Scylla and Tully 1001. Okay. They each add on their own attributes. After trying the code below, add another subclass called AP Student that extends student with a new attribute called AP Score. We can do that. You guys ready? Let's do it. I'm going to write it right in here. I know some of you don't like the indenting. That is tough. All right. I'm going to write it right at the bottom. Class AP Student. It says AP Student is supposed to extend student. Extends student. It says it has its own attribute, an AP score. I am guessing that, so an attribute is an instance variable, so I'll go ahead and make it private. AP scores are ints. They up above say make the AP score, call it A, capital P score. I don't like that at all. I'm just going to say AP score. My constructor. Does an AP student have a name? Yeah, we don't have direct access to it, but they inherit it from person because an AP student, is a person, so they have a name. We just don't have direct access to it. So I still am going to want to be able to name my AP student. Does an AP student have an ID number? Yes, because they're a student. A student has an ID number, so a AP student has an ID number. And then, of course, an AP student has an AP score. AP score. If you're wondering, why did I name these name, ID, and AP score? Well, in this class, there's going to be no confusion over what name and ID are because we don't see name and ID here. I just changed this one to AP score because it can see AP score. What do I need to send to the superclass? Name and ID. I don't have access to those here, but I will go ahead and specify the AP score. That looks like it says AP scare. I'm sorry. It's okay. You guys are all going to get 6s. I'm going to come back and go, boom, 6. They told me I had to teach the class at the university. And we're supposed to override the toString method. If I'm going to override toString, I need it to look exactly like that in the header. Public string toString. I can type it quickly because I've been overriding toString methods since the day I was born. Easy peasy. We have to return some string that's representative of an AP student. Let's see what they did for students toString. For students toString, they just said return super.toString plus the ID. Super.toString was the name inside of student because person was the superclass. Then we tacked on the ID. Here I want the name and ID plus the AP score. I'm going to do return super.toString. That'll give me the name and the ID number. And then I want to tack on a space and their AP score. And if it makes you feel better, you could say this .AP score, but it's really not necessary. Whoops, sorry. There you go. So if you're following the hierarchy, well, objects up at the top, followed by person, then student, then AP student. an AP student is going to have a name, an ID, and an AP score. I think the last thing we're supposed to do is make them. Why don't you make me? That's what I'm doing. All right, we got that. I'm just going to move it up for, I don't know. Can people see it if I go up here? No. Here, I'm just going to do this. Cut it. I'll just paste it here so you guys can still see it when I'm adding a student. Last thing I want to do is make a AP student. AP student A. New AP student. The constructor wants a name, eCalb. It wants an ID number, and it wants an AP score. And then if I go ahead and I print out A, eCalb, ID, AP score. So if you remember where each of these come from, the name comes from the person class. Name comes from person's toString method. Here, I'll make a little key like I'm a map maker. Person. The ID number comes from student's toString method. And then lastly, this AP score on the end comes from AP student. I don't know if that diagram helps anybody. Maybe it helps a single person. I don't know. Questions there? Why should you override the toString method of object? Because it sucks. I agree. I always check the button when I put the videos on YouTube. This is not suitable for children. That's why. Because toString sucks from object. So we need to write our own so it doesn't suck. What a terrible word. All right. Questions on toString? All right, there's one more method. That's really all I have to say about toString because we've been writing toString since you guys were in pull-ups. I don't really have a ton to say about toStrings other than that. We have to talk about the equals method, but why don't we take our 2-minute break first and then we'll do the equals method. All right, the other method from object that we have to be concerned about, no, it's not clone, no, it's not hash code, whatever that is, it's the equals method. Now, let's review really quick. What happens when you compare two objects like this? Ben, thank you so much. Equals equals between two objects compares if they are at the same memory location. And we've seen that that's not always what you want, especially when we're dealing with strings and other stuff like that. So that's bad. I've got bad news. The equals method for object basically behaves the same way. Objects equals method essentially sees if two objects are at the same location in memory. Also unhelpful, also not very usable. So what's the solution? Well, just like toString, which currently sucks, as Daniel so eloquently put it, we're going to make it not suck by writing our own equals method, is the idea here. So it says, one of the important things that gets inherited from the object superclass is the equals method. This method is used to test if the current object and the past object, called obj, are equal. But what does that mean? As seen in the code below, the equals method that is inherited from object class only returns true if the two object references refer to the same object, and like Ben so eloquently put it, they are at the same location in memory. It says try to guess what we'll print out before running it. All right. I see P1, P2, P3. P1 is Kyren. P2 is Jewel, P3 is Kyren, and P4 equals P3. So let's review what's really happening in memory somewhere. Somewhere in memory, P1, there's going to be a name variable that contains Kyren. Where in memory? Who knows? 4, sure. Then somewhere else in memory. Give me another one. 32, sure. There's going to be a name that contains Jewel. Now, even though This next one also contains chiren. We see the keyword new. What does that mean? Another location in memory. 87. Beautiful. And this one also has name equal to chiren. Now, the last thing that I see is that P4 equals P3. What does that mean? Same memory address. So if P3 was located at 87, then P4 is also located at 87. So let's think about these. P1 dot equals P2. True or false? False. Not same memory location. P2 dot equals P3. False. Not the same memory location. P1 dot equals P3. False. Even though they have the same name, and it's a weird one. They're not the same. What about P3 equals P4? True. They are the same location in memory. Now, that is probably not what you want to compare when you're talking about two objects, is their location in memory. Since objects equals method sucks, we're going to write our own equals method, essentially. Yes, okay. So, okay. The equals method inherited from the object class only returns true when the two references point to the same object. I'm going to put that on my notes for the equals method here. I probably should have formatted these differently. I'm sorry. Public Boolean. This is the method header that it must be equals, and it must take in some object. Now, what you name that object is up to you. I usually say object other. That helps me keep it straight. So what does equals do? Well, for object, it compares memory addresses. And that sucks, so we want to write our own. I didn't say it, you guys said it. For object that compares memory addresses. Now, we've also looked at it for strings. Do you guys remember how equals behaves strangely for strings? Okay, but then string does have its own dot equals method. If you don't believe, you could look at the AP quick reference and see that string has its own equals method. It says it returns true if this is equal to other, returns false otherwise. Okay, so string has its own. The goal of this is that we're going to be able to write our own. So the equals method inherited from the object class only returns true when they have the exact same memory addresses. We don't want it to behave like that. We want to compare the attributes. So the idea is we want to override it. So it compares instance variables. Right now, it just compares memory address or like hash, I don't even know. But we want to override it so it actually compares instance variables as part of our class. Okay, so we discovered person does not have a very good object, or does not have a very good equals method. It doesn't actually have an equals method. It uses the one that comes from object, so we would want to override it. What would make two people equal in the case of our person class up here? Well, I only see one attribute, the name, so I would say two people are probably equal if they have the same name. So it's really going to depend on your class. What if we had a class for a right triangle? What would make two right triangles the same? Yeah, probably the same side length. We could probably limit it to just leg 1 and leg 2, because then we're guaranteed they'd have the same hypotenuse, same area, stuff like that. I would not compare the area, though, for two triangles, because it's possible that two triangles have the same area, but they're different, right? What would we do if it were, well, let's go back to the AP students we saw earlier. What would make two AP students the same? Their name, their ID number, and their AP score would make two AP students the same. Essentially what we want to do is be able to compare all the instance variables, or the ones that we choose, and make sure they're the same. So, how do we do that? We want to override the equals method. If you want to change how the inherited equals method works, you can override it so that the new method is called instead of the inherited one. That is what we want to do. The string class overrides the inherited equals method to return true when the two objects have the same characters in the same order as shown in the code below. So down below here you see hi and hi and hi as well. Hi. If you don't remember, there's also some weirdness with the strings. Do you guys remember the string constant pool a little bit? Yeah, there's also that weirdness going on. We can maybe talk about that in a minute. If I were to go ahead and run this though, string has its own equals method, and it just compares the content. So S1 dot equals S2, well, they're different because S1 has hi, while S2 has hi. S2 and S3 are different because this one has hi and this one has hi. And then S1 and S3 are the same because it's hi and hi. Same exact spelling, capitalization, all that stuff. And if you don't remember the string constant pool weirdness, I guess I could maybe demonstrate it really, really quickly. If I make maybe one more of these, and then here I'll print out something like this, weird, and then I'll do S1 equals S4. I don't know, something like that. That should have been true. I don't know what's happening. Never mind. I'm out of here. I think it's the weirdness because it's in here. That should have used the string constant pool to put hi and hi in the same spot. Oh well. Doesn't matter. But the main point is that string has its own dot equals method that actually compares the contents of two strings. And that's what we basically want to do for our other classes. So it says any class can override the inherited equals method by providing a method with the same method signature, including the method name and parameter list and return type. The provided method will be called instead of the inherited one, which you guys already know. We've been overriding methods for a while now, which is why we say that the new method overrides the inherited method. The person class below overrides the inherited equals method. Let's check it out. So a person, remember, just has a name. So for two people to be equal, they must have the same name. Look at their equals method. I'm just going to let you read it for a second. I'll shut up. All right, let's dissect bit by bit of this method. The first line, line 13. It's a little bit strange because you're thinking, I want to compare two person objects. Why is this method taking in a capital O object instead of a person? Any idea there? That's exactly right. Just like we have to say public string, toString, no parameters to override the toString method properly, objects equals method is passed in an object. So to actually override it properly, we have to have the exact same type of parameters. If you put person here, you are not actually overriding the equals method. You must put object as the type that comes in. Now with that being said, when you call this method, a person will hopefully be passed in because you want to compare if two person objects are equal. So then the very next line is a cast of other to person. We talked about this yesterday. This is legal if the actual type of other is a person. So assuming somewhere else, there's been some person created, person D equals new person Noah, something like that. As long as their actual type is person, I could pass D in for other, and then I could immediately cast it. Why do you have to do that? Well, it's because it's currently an object. I'm not going to be able to see its name or any of its other instance variables or methods of any of that if it's an object. I have to cast it as a person so I can look at those things. I have to basically change its declared type. So I'm changing the declared type here on the first line by doing a typecast. Then essentially we say two people are equal if their names are equal. After doing the cast, down below, we essentially compare this person's name. Is this required here? I don't think I need to write this, but it basically says which objects are you comparing. Well, if I go ahead and let's say I do something like this, person A equals new person Jenny, and person B equals new person Xander. If I do something like that, if I go ahead and say print A dot equals B, something like that there. A is going to be this. It's the one that calls the method. So Xander, or no, Jenny would be this dot name. And then you want to see if it's equal to B, the other person's name. This is the other person's name. So then you're seeing if this person's name is equal to the other person's name. So you take in an object, you can immediately cast it as that subclass, its actual type, and then you just check whichever instance variables you want to see are equal. Now here, a person just has a name. So he's just saying name. Yeah?
Is that calling the string equal?
Very good. What is the type of this dot name? This dot name is a string. And so when I do string dot equals, Ian correctly said, yeah, this is the equals method for string that's being called. So that's even another layer that's on top of all of this. We're comparing two people by comparing their strings using strings equals method. Why am I not using equals equals? Because I wasn't born yesterday. I know better. I was raised better than to compare two strings using equals equals. Okay. So let's go ahead. Hey, look at this. Gabe, and Gus. Let's see. Why are some of these true and false? P1 and P2, they have different names, so they're false. P2 and P3, they are different names, so they're false. P1 and P3 are the same name, so that is true. P3 and P4, they're going to be true for two. Well, basically they have the same name because they're the same person. So that's true there. If I did not have this equals method, I'll just take it out for a moment. You'll notice that the results change a little bit because then it's not just comparing the name. So I want to make sure that I have an equals method in here so that I'm actually comparing the name. Now, what would that look like for other things? Well, you would write the same line for line 13. You would do the same cast, but to a different type, and then you'd probably compare other stuff. So that's what we're going to look at next. But I want to write down on my note sheet that it must have, I don't know, that header, the right header. This one up here. It must have this header up here. Which means it must take in an object, which means we must do some casting so we can actually see the instance variables and do stuff with it. Because an object itself does not have a name. We have to do a cast so we can see those methods, those variables, stuff like that. If you're wondering why can I see the private instance variables, well, think about where we're writing this method. I'm writing it from inside a person class so I can see any of the private variables from inside the person class. Does that make sense? All right, I'm guessing some people have questions about this equals method. Daniel, are you okay? Okay, good. All right, well, I'm going to keep going here. It says you can step through the code. I'm not going to do that. To write your own equals method. Here's what we're looking for. To write your own equals method, you must, 1, use this exact method signature. Hey, we just wrote that down. Typecast other to your class name, and then return the object's attributes equals the other object's attributes. Return whether this object's attributes, okay. You might want to write that down. I'm going to try to write it down as well. So maybe this bullet point I just wrote, maybe I'll just change that to a number 1. 1, must have the right header. 2, type cast other to the correct type. So if you're in the person class, cast as a person. If you're in the triangle class, cast as a triangle. If you're in the whale class, cast as a whale, etc., etc. So this object other that comes in up here, you need to make sure that you are casting it to the correct type. So maybe I'll just write something like that here. I'll write down like person, other person, equals, and I'll just do a cast on other. So that's step 2. Typecast other to the correct type, whether it's a person, a triangle, a square, a whale, whatever it is, a blue tooth, blue flute, moo, shoe, whatever. You need to cast it to the correct type. And then step 3, what did it say? Compare the attributes correctly. Compare this as attributes to the other ones. This just says return whether this object has the same has equal as has instance variables equal to the other one's instance variables. Return whether this object instance variables are equal to the others. Now keep in mind, if those instance variables are ints, you can compare them using equals equals. If they're doubles, you can compare them using equals equals. If they're booleans, you can compare them using equals equals. If they're strings, you compare them using dot equals. If they're other objects, compare them using dot equals. Maybe they have their own dot equals method. But you need to return whether this object's instance variables are equal to the others. Now, which instance variables? More often than not, it's all of the instance variables are equal. So, for example, the person just had a name, so we compare if this name is equal to the other one's name. If it's an AP student, you compare if their name, their ID number, and their AP scores are the same. If it's a right triangle, maybe just leg 1 and leg 2. It just depends on the class. Does that kind of make sense? So I'm just going to write the example that they had. I'll do something like return this dot name, and I use dot equals here because that's a string. Hit me with the blue, please. There we go. Other person dot name. And again, if you're wondering why is that a dot equals instead of equals equals, well, this name and other person name are both strings. And the correct way to compare strings, well, you know this, is using dot equals. It's not using equals equals. Okay. So those there are the 3 steps to overriding the equals method and writing your own. toString's relatively simple. The equals method is a little bit more challenging. Do you think it's possible if we're in the AP student that student has its own equals method? Let me go back a step. Do you think it's possible if we're in just student that if person has its own equals method, how could I call person's equals method from student's equals method? Super dot equals, and then if I'm all the way down in AP student, I can do super dot equals to call student's equals method, which would in turn hopefully call person's equals method. So just like you override toStrings and use super dot to call levels up, you can do super dot equals to call levels up equals method. Questions so far? Maybe we write one? Okay. It says, if you need to check multiple attributes, for example, a name and an address, you can use AND to combine tests. So here they're seeing if the 2 attributes are equal and the second attribute's equal and you can AND together as many things as you want to, really. If you're writing an equals method for a subclass, you can call the superclass equals method using the super keyword to check the attributes in the superclass and then check the attributes in the subclass. Something like that. Interesting. There's a programming challenge. You guys want to do it together? All right. Come on, you guys. Come on. Last one here. Let's do it together. Let's do it. We got this. We got this. Okay, let's see what this is. It says in the following code, a bank account class contains the account holder's name and the money balance in the account. Is that true? Let's see. Account has a private string name, a private double balance. Okay, I see the constructor. All right, looks good. That makes sense to me. Does it make sense to you? Name and a balance. Okay, it's an account. Got it. It says work in pairs. We're going to be a pair of like 30. Write a toString method for a count that returns the name and balance with a comma in between. All right, let's do it. Basically, anywhere in a count you can do this. The method header for the toString method must be exactly public string to string, no parameters. It must exactly look like that. And what did it say? Have the name, comma, balance? Name, comma, balance. Return name, comma, maybe a space, balance. Ooh, do you want a dollar sign in front of the balance? Let's be fancy. All right. So that's a toString method. We just overrode the toString method for object. How do you know? Well, because this class is a subclass of object, because all classes are, and it has the exact same method header, public string toString. All right. It says 2, write an equals method for a count that checks the name and the balance are equal. All right, this is where it gets tricky. We got to follow our steps from before. The method header must be exactly public Boolean equals, and then it must take in a what? An object. And we usually say object other, because there's this object and there's the other object. This is the one that calls the method. A dot equals. A would be this. Am I out of tissues? Here. I got. Don't worry, I went to Costco. Hey. You got it. Oh, Daniel, you're not on my fantasy team anymore. All right. It's okay. Step 1, we write the method header. What's step 2? Cast. So I have to take this account. Maybe I'll call it other account. And I'm going to cast it as an account. So this basically takes whatever other is and turns into an account. And it's only going to be legal if its actual type is account, if it were created using accounts constructor, essentially. All right. It says check that the name and the balance are equal. Whose name? This is name and other's name, and this is balance and other's balance. So I'm going to return. Let's compare the names first. We're good at that. I'm going to say this dot name. You technically don't have to say this dot name. You can just say name because the this is implicit, but I think it looks better. This dot name dot equals other account dot name. Just give you 1 second for that to sink in. If you're not sure what's going on, when you call this method and say a dot equals b or something like that, a is going to be this, b is going to be other. So it essentially checks if a's name is equal to b's name. Does that make sense so far? And I want to see if the account balances are the same. So I'll do and this dot balance. How am I going to compare the balances? Equals equals, because the balance is a double. How do I know? Because it says right up here on line 4. So I'll do and this dot balance equals equals other dot balance. No. Other account dot balance. Sorry, I'll try to make it. I can't make it wider. I can make it smaller. Unhelpful. So both of those things have to be true for the whole thing to be true. Questions? Woo! Okay, write a subclass called savings account that extends count and adds an interest rate variable. We got time. We got plenty of time. Yeah. I don't know if you guys have any energy left in you, but we got plenty of time. We got plenty of time. It runs, it compiles, it's good so far. Okay. We're supposed to make a savings account that has one extra instance variable called an interest rate. I'm guessing that's a double. Private double interest rate. What does it say? Make a constructor? Write a toString? Well, we should probably make a constructor first. We have to, I guess. Public savings account. Does a savings account have a... Oh, I forgot something. What did I forget? Extends? Sorry. That's embarrassing. It's not the first time I've embarrassed myself. All right. Savings account constructor. Savings account does have a name. Is that what goes first? Yes. So I'll do a string name. It also has a double for the balance. And then it also has a double for the interest rate. I'm just going to put IR there. Why am I naming these name and balance? Because it can't see name and balance here. It can only see the interest rate. That's why I only changed the name of the parameter representing the interest rate. Where do I send the name and the balance? You know where they're going. They're going up to account. They are ascending. And then I'll go ahead and change the interest rate. There's my constructor. Now, it didn't even tell me I had to write a constructor, but I knew I had to write a constructor. You know how I knew? Because there's no default constructor in account. And if there's no default constructor in account, that means that if I don't create a constructor here, it's going to try to call the default constructor from the superclass, and that's not going to work because there isn't one. So, I needed that guy. All right, what does it say then? Write a toString that returns a call to super toString and the interest rate. Easy peasy. ToStrings must always look like public string toString. Now what I want is the name and the balance plus the interest rate. Where do the name and the balance come from? Super.toString. And then I'm just going to tack on the interest rate. Right? So that's going to give me the name, comma, the balance, comma, the interest rate. Super.toString is the name and the balance. Last thing, it says write the equals method. Write an equals method for savings account that calls the superclass's equals method and checks that the interest rates are equal. Okay. The equals method must always look like public boolean equals object other. Just get used to writing that. That's how you always write it. If you're going to override objects equals method, you got to write it exactly like that. That's step one. What's step two? Cast. So I'm going to go ahead. Now, what type am I going to cast other to? Savings account. So I'm going to say savings account, maybe other savings equals savings account. Other? Nope. Other? Now I want to compare the balance and the name first, and if those are equal, then I also want to compare the interest rate. Do we have a method that already compares the name and balance? Yes. Where does that exist? Superclass. So I'm going to say return super.equals other savings. And I know what some of you are thinking. Didn't the equals method for the account expect an object? Yeah. Is a savings account an object? Yeah. And I need to see that their interest rates are the same. So, and this dot interest rate, that's a hard word to spell, equals other savings dot interest rate. So, Annie, yes, go ahead. I'm sorry, I didn't hear anything you said. Why didn't we write anything in the main method? If I had like 3 more minutes, I would have made some objects and compared them. I'm just running out of time here. The main method was going to be there to prove it worked. But you're just going to have to mentally say, okay, it worked. Other questions? All right, what's the cosmic superclass? Object. All other classes inherit from it. Why is that important to us? There's 2 methods that we want to override from it. What are those 2 methods? toString and equals. Okay. toString, relatively straightforward. Equals is a little bit trickier. You might need to review some of the lesson if that was, a little bit tough. That's okay. Really quick. Homework over the weekend. Sorry. Is there another teacher in here? Sign up for the AP test. I think you still have some time. Is that true? Yeah. Okay. All right. And there are those progress check questions. We are done now with this unit. We're going to do a project next week on it, but the progress check questions, the multiple choice progress check questions from the College Board. You are going to have to go on AP Classroom, and I've assigned the progress check questions for this unit. So there's some multiple choice questions to do over the weekend. Yes, Zoe?
How many units do we have left to do?
One. We're kind of doing but that'll be next try, and we're going to do recursion, some searching and sorting. And then it's just getting better. Which is hard for us because we're already so good. But then after that, it's just getting better. It's just getting better. So just one more. Again, sign up for the AP test. The big thing for you guys, the multiple choice progress check. I'm going to put another announcement on the classroom, but please log into the AP Classroom and do the multiple choice progress checks. I am going to give credit for them being done, or not.
Oh, you're going to give credit if we don't do it.
I'll give you the credit you deserve if you don't do it. All right. Daniel, it wasn't meant like that. I know you're going to do it. Have a good weekend!